We'll start in about 2 minutes. Okay, it's 8 o'clock. Today in section 6.4, we'll discuss a general strategy for factoring. So on some tests, you won't be told what kind of polynomial you're looking at. You'll have to figure that out on a case-by-case basis. So here's a general strategy for factoring. As always, if the greatest common factor is not equal to 1, then factor the greatest common factor out of all of the terms first. Then watch out for special forms. This one, a to the second plus 2ab plus b to the second. This is a perfect square trinomial, and the two factors are a plus b times a plus b. And to the right, we have another perfect square trinomial, a to the second minus 2ab plus b to the second. Its two factors are a minus b times a minus b. Then another special form, a difference of two squares, a to the second minus b to the second. Its factors are binomial conjugates. So one factor is a plus b, and the other one is a minus b, or vice versa. A to the second plus b to the second. That is a sum of squares. And in this course, we don't factor a sum of squares. It can be factored. If you want to learn how to factor that, take college algebra. But for here, we just say not factorable. Not factorable over the real numbers. A sum of cubes can be factored, a to the third plus b to the third. The binomial factor is a plus b. And then the trinomial is a to the second minus ab plus b to the second. And then a difference of cubes can be factored, a to the third minus b to the third. The binomial factor is a minus b. And the trinomial is a to the second plus ab plus b to the second. Okay, the third step in this general strategy, if you have a trinomial of the form ax squared plus bx plus c, then try using the AC method to factor that. Then step 4, if the polynomial has 4 terms, then attempt to factor that by grouping. And then step 5, you can always check your factoring by multiplying. Okay, we'll look at some polynomials in no particular order. We'll just take them one at a time and see if we can factor them. So this first one, 7b to the second plus 7b minus 42. I'll give you a minute or two to get started on that one. See if you can factor that. Okay, let's start. Well, if you follow the general strategy, step 1, if the greatest common factor is not equal to 1, factor that out. So of these 3 terms, 7 is a common factor. So we should factor 7 out first. So we get 7 times the quantity b to the second plus 1b minus 6. And then we want to see if we can factor the trinomial b to the second plus 1b minus 6. So let's look at that down here by itself. So remember, if you have a variable by itself, it's understood that the coefficient is 1. So I'll write the coefficient here, b to the second plus 1b minus 6. And the coefficient of b to the second is also 1. If we apply the AC method, we multiply 1 times negative 6, which is negative 6. And we want to see if we can find 2 integers that have a product of negative 6 and a sum of positive 1. So it doesn't take too long to find that 3 and negative 2. 3 times negative 2 is negative 6, and then 3 plus negative 2 is positive 1. So that means that we can factor b to the second plus b minus 6. Okay, so I'll squeeze that in down here. We'll transform the trinomial into a quadronomial. We'll write b to the second minus 2b plus 3b minus 6. And then we factor by grouping. So we'll continue the factoring down here. Out of the first 2 terms, we can factor out b. So we get b times b minus 2. Then the middle operator is addition. Addition. Out of the 3rd and 4th terms, we can factor out 3. So we get 3 times b minus 2. And then factor b minus 2 out, so we get b minus 2 times b plus 3. Okay, so up here we write the complete factorization, including the factor 7, so we get 7 times b minus 2 times b plus 3. This next one to the right, we have a quadronomial, 15rt minus 15r plus 12t minus 12. So in the general strategy, step 4, if the polynomial has 4 terms, attempt to factor by grouping. Factoring by grouping doesn't always work, but you can always try it to see if it will. So we'll try it here. Out of the first 2 terms, 15rt and minus 15r, the greatest common factor is 15r. So we'll factor 15r out, and we're left with t minus 1. The middle operator is addition. And then out of the third and fourth terms, we can factor out 12. And the other factor is t minus 1. And then when we factor t minus 1, the other factor is 15r plus 12. So is that the complete factorization? No. So I didn't apply the first step in the general strategy. Identify the greatest common factor of all of the terms. And if the greatest common factor is not 1, factor that out. So in our process down here, we can still get the complete factorization. When you look at 15r plus 12, what's the greatest common factor of 15r and 12? 3. So we could write this. It's more customary to write the numerical factors to the left. So I'll write the greatest common factor 3 out on the left, and then t minus 1, and then 5r plus 4 for the other factor. But it might have been less confusing if we had done that right from the start. Okay, but let's move on to the next one, k to the 4th minus 16. So k to the 4th minus 16, well, it falls into a couple of categories, one that we haven't talked about. One category that we did talk about is that this is a difference of squares, but it's also a difference of 4th powers, which is a little bit more advanced than what we're going to do in this class. But if you think of k to the 4th as k to the 2nd to the 2nd, and think of 16 as 4 to the 2nd, then factor this as a difference of squares. So something squared minus something else squared. We have k to the 2nd minus 4 times k to the 2nd plus 4. Okay, now look at what we have. K to the 2nd minus 4 is also a difference of squares. This is k to the second minus 2 to the second. The other one, k to the second plus 4, is a sum of squares. So we'll go ahead and factor the difference of squares. K squared minus 4 is the same as k minus 2 times k plus 2. And then we multiply those by k to the second plus 4. So in this class, that's as far as we'll factor k to the fourth minus 16. Okay, the next one, y to the sixth minus 1. We saw something kind of like this yesterday. Different terms. This is a difference of squares. It's also a difference of cubes. One squared is 1, and 1 to the third power is also 1. So if we interpret it as a difference of squares, then think of y to the sixth as y to the third to the second, and think of 1 as 1 to the second. And then factor the difference of squares. So something squared minus something else squared, one factor is y to the third minus 1. The other factor is y to the third plus 1. But y to the third minus 1 is a difference of cubes, and y to the third plus 1 is a sum of cubes. So we know how to factor those. So we'll factor y to the third minus 1 first as a difference of cubes. So the binomial factor is y minus 1. The trinomial is y to the second plus 1y, or just plus y, and then plus 1. And then when we factor the sum of cubes, y to the third plus 1, the binomial is y plus 1. And the trinomial is y to the second minus 1y, or just minus y, plus 1. So that is the factorization. So y to the sixth minus 1 is pretty loaded. Y to the sixth minus 1 is a more compact way to represent the product of those factors. Okay, let's move on to the next page. So more factoring. Okay, factor the following polynomials: x to the second plus 27 times xy minus 58 y to the second. The greatest common factor is 1. So what should we try next? Well, although the first term, x to the second, is regarded as a perfect square because we're squaring x, the term on the right is not a perfect square. 58 is not a perfect square. Well, it's a trinomial. It has two different variables in it, but we can still attempt to factor this using the AC method if we just apply the AC method to the coefficients. The coefficient of x squared is 1. So the value of A is 1. B is 27. That's the coefficient of x times y. And C is negative 58. So when we apply the AC method, so AC method is what we're doing. We just multiply the coefficients 1 times negative 58 to get negative 58. And then we try to find two integers that have a product of negative 58 but add up to positive 27. It doesn't take too long to figure out what those are, but let's review the systematic method for finding those two integers. So remember what we're trying to do. We're trying to find two integers that have a product of negative 58 and a sum of positive 27. So what does that mean? That means if the two integers exist, one must be positive and one must be negative, because when we multiply them, we get a negative. So one is positive, one is negative. Since the two integers have to add up to a positive 27, that means among those two integers, where one is positive and one is negative, the one with the largest absolute value has to be positive, since the two integers have to add up to positive 27. Okay, so in our systematic approach, we start at the extremes. We're picking integers that have a product of negative 58, but we pick them in such a way that the one with the largest absolute value is positive. So the first pair is negative 1 times 58. The product is negative 58, but these add up to positive 57. What's the next pair in this systematic approach? Yeah, negative 2 and positive 29. Negative 2 and positive 29. Those have a product of negative 58, and they add up to positive 27. So negative 2 and positive 29 are the two integers needed. That means this can be factored. So we transform the trinomial into a quadronomial. We're going to replace the plus 27xy with minus 2xy plus 29xy. So we turn it into a quadronomial and then factor by grouping. So keep in mind, since we found the two integers that satisfy both conditions, that guarantees that we can factor it. So if we come up with something that doesn't make sense, it means we have to go back and look for the mistake that was made. So out of the first two terms, x squared minus 2xy, factor out the greatest common factor, which is x. Factor x out, and the binomial is x minus 2y. Then the middle operator is addition, so bring down addition. And then out of the third and fourth terms, 29xy minus 58y squared, the greatest common factor is 29y. Factor 29y out, and we're left with x minus 2y. At each stage, you can check your factoring by multiplying. Hey, but since the binomials match, x minus 2y is in both places, that is a good sign. So we factor x minus 2y out, And the other factor is x plus 29y. Okay, then if you want to verify that you have the right factors, then multiply them. Okay, let's try the next one. 14c to the second minus 29c plus 12. Take a couple of minutes and see what you come up with using the general strategy for factoring. So how many have a result? Does anybody online have an answer? Yeah, I got one answer. Well, I got an answer of no online. All right, let's go through this step by step. The greatest common factor of all three terms is 1. So we try the AC method. This doesn't look like a special form of any kind. So we try the AC method. Oh, 14 times 12 is 168. We want to see if we can find two integers that also have a product of 168 and add up to negative 29. Hey, if the product of two integers is positive and they add up to a negative, what must be true about those two numbers? Yeah, they must both be negative. So let's go through the systematic approach. It won't take too long. We're going to pick pairs of integers where both are negative and whose product is 168. So at the extremes, -1 times -168, those add up to -169. Then -2 times -84, those add up to -86, so we're getting closer. -3 times -56. So that's not the pair that we want. -4 times -42. Those add up to -46. -5 is not a factor. -6 times -28. Those add up to -34. We're getting closer. And then -7 times -24. Those add up to -31. And then -8 and -21. Those do add up to -29. So those are the two that you got. Okay, so this guarantees that we can factor this because we found two integers that have a product of 168 and a sum of -29. So we transform the trinomial into a quadronomial. We replace the -29c with -8c minus 21c. You could do that in the other order if you want. It doesn't matter. But then we factor by grouping. Out of the first two terms, we factor out 2 times c, the greatest common factor. And then we're left with 7c minus 4. The middle operator is subtraction. So bring down the middle operator. This reminds us to factor the negative of the greatest common factor out of the third and fourth terms. The greatest common factor of the third and fourth terms is 3. So we want to factor out -3. And then we'll be left with 7c minus 4. Hey, you can always check your progress by multiplying. And then if everything checks out, then factor 7c minus 4 out. The other binomial is 2c minus 3. Hey, let's do some more. 63n to the second plus 150n plus 75. Hey, what's the first step on this one? Yeah, the greatest common factor of all three terms is 3. So factor 3 out of all three terms. So we get 3 times 21n to the second plus 50n plus 25. And then we try to factor the trinomial that's inside the parentheses. So in other words, take a couple of minutes, apply the AC method to that trinomial, 21n to the second plus 50n plus 25. Okay, what did you come up with? How much? 30 times 35 times 15. So let's try that. 35 times 15. I know that that's 35 times 10 plus 5. 35 times 10 is 350. And then 5 times 35 is 175. And those add up to, those add up to 525. And that is the same as using the AC method, 21 times 25. And 35 plus 15 does equal 50. So that means we can factor further 35 and 15. So let's look at this by itself with those two numbers, and then afterwards we'll include the factor 3. So 21n to the second, and then replace plus 50n with plus 35n plus 15n plus 25, and then factor by grouping. Out of the first two terms, we can factor out 7n. And the other factor is 3n plus 5. Bring down the middle operator of addition. Out of the third and fourth terms, we can factor out 5. And then 3n plus 5. And then the binomials match, 3n plus 5. So 3n plus 5 times 7n plus 5. Then the complete factorization of the original polynomial has to include the factor 3. So we have 3 times 3n plus 5 times 7n plus 5. All right, well, that worked out pretty nicely. Let's try the next one, v to the second minus 25vw plus 46w to the second. The greatest common factor is 1. So even though we have two variables, v and w, we can still apply the AC method. So I'll just point out something. The term on the left involves the square of the variable v to the second. The term on the right has w to the second. And the middle term has v to the first and w to the first. So if you ever have two variables in a trinomial, in order to be able to apply the AC method, it has to follow the same pattern. Okay, well, the greatest common factor is 1, so we multiply 1 times 46, because 1 is the coefficient of v to the second. And then look for two integers that have a product of positive 46 and a sum of negative 25. If the product is positive and the sum is negative, they both must be negative. So this one won't take too long. If we start at the extremes, -1 times -46, those add up to -47. And then -2 times -23, those have a product of +46 and a sum of -25. So -2 and -23 are the two integers that we need for that one. So transform the trinomial into a quadronomial. So v to the second minus 2vw minus 23vw plus 46w to the second. Okay, then factor by grouping. Out of the first two terms, we can factor out v, and the binomial is v minus 2w. And the next step, the middle operator in the quadronomial is subtraction. So bring down subtraction. And then factor the negative of the greatest common factor out of the third and fourth terms. So that means we're going to factor out -23w. And we'll be left with v minus 2w. And then the last step, factor v minus 2w out. And the other factor is v minus 23w.
I'm curious, on the when you're doing the AC method, does it matter if your -2 comes before the -23 VW, or can you flip flop those?
The order of the middle terms?
Yeah.
It doesn't matter. It'll work either way. You just have to make sure you're careful with the signs,
I think carry.
as always. Hey, let's move on to the next page. This one, 8m to the third plus 27n to the third. So what do we do on this one? Well, we note that it is a special form called a sum of cubes. The coefficient 8 is a perfect cube because 2 to the third is 8. And the other coefficient, 27, is also a perfect cube because it's 3 to the third. So you can rewrite this so that it's more apparent that it's a sum of cubes. If you raise the term 2m in parentheses to the third, that's the same as 8m to the third. And then if we add that to the term 3n in parentheses to the third, then it's more apparent that we're looking at a sum of cubes. Okay, so I'll rewrite the sum of cubes factoring formula down here. If you have a to the third plus b to the third, the binomial factor is a plus b. And the trinomial is a to the second minus ab plus b to the second. Okay, so for this one, the binomial is 2m plus 3n. And then the first term in the trinomial is what we get when we square 2m. So if we square the term 2m, we get 4m to the second. And then we're going to subtract the product of 2m and 3n, which is minus 6mn. And then we're going to add what we get when we square the term 3n, which is 9n to the second. Okay, so that's the factorization of that sum of cubes. Okay, the next one, 1000x to the third minus 729t to the third. So this one is a difference of cubes. 1000 is 10 to the third, so 1000 is a perfect cube. 729 is 9 to the third, so 729 is a perfect cube. So we can rewrite it. Instead of 1000x to the third, we can write the term 10x in parentheses to the third, because 10x times 10x times 10x is 1000x to the third. And from it, we can subtract the term 9t in parentheses to the third. So now it's more obviously a difference of two cubes. The difference of cubes factoring formula, a to the third minus b to the third. The binomial is a minus b. And the trinomial is a to the second plus ab plus b to the second. Okay. So the binomial here then is 10x minus 9t. And the trinomial, the first term in the trinomial is what we get when we square 10x. So that will be 100x to the second. And then we're going to add the product of 10x and 9t. So we add 90xt. And then we add what we get when we square 9t, which is 81t to the second. Okay, the next one. What do you get for that? 25x w to the second plus 100x. Hey, what's the greatest common factor?
25x.
Yeah, 25x. 25 goes into 100 4 times, and both have x. So we factor the greatest common factor out first, 25x, and then w to the second plus 4, because 25x times 4 is 100x. And then what? In Math 1108, this is as far as we go. W to the second plus 4 is a sum of squares. So we don't factor a sum of squares in this class because it involves numbers that are not real numbers. So this is the complete factorization. So since we were able to factor the original polynomial at least this far, then this is the factorization. We don't take it any further. But if you were to answer not factorable, then that would be incorrect because we did factor it this far. See what I mean? Hey, we're down to less than a minute. This one, 81c to the second plus 54c plus 9. Well, we're out of time, so you can work on the other ones. If you can't figure them out, send me an email and I'll help you with it. But that's all for today.